Practice a gas stoichiometry problem. Here we go. Calculate the volume of carbon dioxide adjusted to 25 degrees Celsius and 1 atmosphere that plants need to make 1 gram of glucose. Here is the balanced chemical equation. 6 moles of carbon dioxide will react with 6 moles of water to produce 1 mole of glucose and 6 moles of oxygen. This is the classic photosynthesis reaction. All right, to work this problem, the first thing we need to identify is what's given. In this case, what's given is 1 gram of glucose, C6H12O6. We want to see how much in volume of carbon dioxide it takes to make that amount of product. All right, so what's wanted then is how many liters of carbon dioxide will be needed at a temperature of 25 degrees Celsius and a pressure of 1 atmosphere. Okay, so in order to work this problem out, we are going to have to convert from really the given, which is the desired amount of product, and from the wanted, which is how much of this reactant do we need to get that desired amount of product. So the conversion path is going to be from grams of glucose, C6H12O6, to moles of glucose. And the reason, of course, why we have to convert to moles of glucose is because our relationship is across this balanced chemical reaction. And we know that for every 1 mole of glucose that we make, it takes 6 moles of carbon dioxide. So then we'll have to convert from moles of glucose to moles of carbon dioxide. All right. Once we're in units of moles of carbon dioxide, we are going to need to convert to liters of carbon dioxide. All right, so that's the plan. How are we going to get there? Well, whoops, wrong way. How are we going to get there? Well, let's see here. We need to figure out what our conversion factors are going to be. To convert from grams, and I'm going to rewrite them down here where I have more space, grams of glucose to moles of glucose. The conversion factor, C6H12O6, the conversion factor to get from grams to moles of a particular compound is going to be the molar mass. Okay. To get from moles of glucose to moles of carbon dioxide, you're going to need to use the reaction stoichiometry, which is the molar ratio. All right, and in this case, the molar ratio is, let's see here, 1 mole of, it's assumed 1 mole of glucose for every 6 moles of carbon dioxide, so it's a 1 to 6 molar ratio. All right, and then it's a 1 to 6 molar ratio from glucose to carbon dioxide. And then we need to convert to liters of carbon dioxide. How do we do that? Well, there's 2 ways to do it. Once you have the moles, and they gave us the conditions, the pressure and temperature, you can use the ideal gas law as a conversion factor. Because once we'll have the moles, we can calculate, essentially, the algebraically calculate the liters. Or if we knew the molar volume under these conditions, we could use the molar volume as a direct calculation. We'll try that first, then we'll use the ideal gas law second. Okay, let's get started. All right, so we're starting with 1 gram of glucose, and we need the molar mass of glucose. And if you look up on the periodic table, 6 moles of carbon would be 6 times 12 plus 12 times 1 molar mass for hydrogen plus 6 times 16. That is 180, so the molar mass is 180 grams per mole. But I'm going to put it in my calculation with the gram unit on the bottom, so it's 180 grams of glucose per 1 mole of glucose. Now I'm in units of moles of glucose, because the gram unit's going to cancel. So then to get from moles of glucose to moles of carbon dioxide, I already looked at the equation and it's a 1 to 6 molar ratio. So I need to cancel the glucose, so it's 1 mole of glucose from the balanced chemical reaction is produced for every 6 moles of carbon dioxide consumed. So my mole glucose unit cancels. At this point, I could calculate the number and determine the number of moles of glucose that I have, and then plug that into the ideal gas law, solving for volume. Or if I knew the molar volume under these conditions, which as it turns out, 25 degrees Celsius in 1 atmosphere is another very standard condition. It's not the standard temperature and pressure, but in this case, the molar volume at 25 degrees Celsius, that's 298 Kelvin in 1 atmosphere, is also well known, whereas its regular STP is 22.4. Under these conditions, the molar volume is 24.46 liters per mole, 1 mole. Okay, so since that is a well-known quantity, I can put that in right here and say for every 1 mole of carbon dioxide at 25 degrees Celsius in 1 atmosphere, I found that number in a table. The molar volume is 24.466 liters, in this case of carbon dioxide. So in that way, I can very easily calculate the volume of this number of moles of carbon dioxide is going to be 0.75 liters of carbon dioxide. Okay. Alternatively, if I wanted to use the ideal gas law to calculate this gas stoichiometry, or excuse me, the liters, then I would have the ideal gas law PV equals nRT, solve for V equals nRT over P. I'd plug in the value that I got from moles for my calculation, the R value, 0.08206, the temperature here, 25 degrees Celsius or 298 Kelvin, the pressure 1 atmosphere, and when I plug all those values in, I also get 0.75 liters for my volume of carbon dioxide needed to make 1 gram of glucose. So either way is fine. Whichever way you're more comfortable doing will get you to the right answer.